So we have here our first example. The first example, that is the integral of e negative y hyperbolic function of sine y dy. So from definition, the hyperbolic function of sine, that is equivalent to e to the y minus e negative y over 2. Okay. So from that, we can substitute the value of hyperbolic function of y to e to the y minus e negative y over 2. E negative y, okay, substitute e to the y minus e negative y over 2 dy. For that one, we are going to multiply e negative y inside. The integral of e negative y times e to positive y, that is equivalent to e to the 0. So e to the 0, that is equivalent to 1. Okay. So we will have 1/2 dy minus the integral of e negative y times e to the negative y. We are going to add the exponent. So negative y plus negative y, that is e negative 2y. So you will have e negative 2y over 2 dy. So therefore, you will have the integral of dy, that is equivalent to y. So we will have here y over 2. But then here, you will have the integral of, okay, for the integral of e negative 2y, our u then, u here, that is equivalent to, so I will write it here. So you will have 1/2 the integral of e negative 2y dy. Okay. So e negative 2y, so you will have, or u here is negative 2y. So u is equal to negative 2y. So du, that would be equal to negative 2 dy. So therefore, you will have y over 2, and then you will have 1/2 integral of e negative 2y du is negative 2 dy. Okay. So we have now a form of e to the u du, wherein our du is negative 2y. So we are going to multiply, okay, we are going to multiply negative 1/2. So multiply here negative 1/2. So therefore, this would become positive, okay, positive. So we will have times 2 here. Okay. So our final answer, that would be equal to, so our final answer will be equal to okay, y over 2 plus 1/4 the integral of e negative 2y negative 2dy. Okay, so therefore you will have y over 2 plus 1/4 e negative 2y plus c. Okay. That is now the final answer. So we have this one. Okay, that is now the final answer. So we will have our next example. Our next example, that is the integral of sine 2x e cosine 2x dx. U is equal to cosine 2x. Derivative of cosine, that is negative sine 2x. Derivative of 2x, that is 2 dx. So therefore our du, that is equivalent to negative 2 sine 2x dx. So the integral of, okay, we will rearrange e to the u, e cosine 2x, and then our du, that is negative 2 sine 2x dx. Since we multiply negative 2, so we will multiply negative 1/2. So this one, this is our du. Okay. This one is our e to the u. So our final answer, because this is a complete form of e to the u du, so proceed now to the formula. Negative 1/2 e to the u, so you will have e cosine 2x. So e cosine 2x plus c. Okay. So that is now our final answer. So that is our final answer. The next example, we have the integral of x e to the negative x squared dx. So our u here, that is equal to negative x squared du, that is negative 2x dx. So therefore, proceed to the solution. The integral of e negative x squared, okay, negative 2x dx. So since we multiply negative 2 for our du, so multiply negative 1/2. We have now a form of e to the u du. This one is du. This one is e to the u. So therefore you will have negative 1/2. So e to the u, e negative x squared plus c. So that is now the final answer. So that is the final answer. We have our next example. That is the integral of e to the x plus e minus x squared dx. Because that is e to the x plus e minus x squared, so we are going to expand. So we have here the solution in expansion. You are going to multiply e to the x plus e to the negative x times e to the x plus e minus x. That is e to the x times e to the x, that is e to the 2x you are going to add the exponent, the same basis, plus e to the x times e to the negative x. So this one, e to the x, e negative x. Then you will have e to the x times e negative x. So you will have e to the x times e negative x. Plus, okay, plus e to the negative x times e to the negative x, add the exponents. So that's the reason you will have e negative 2x. So bring this down, e to the 2x, e to the x times e to the negative x. When you are going to add the exponent, that becomes 0. So e to the 0, e to the x times e to the negative x, that is positive x, negative x, that is e to the 0. Bring down e to the negative 2x. By definition, e to the 0, that is equivalent to 1. So, that's the reason we have here 1. Or any number or anything that is raised to the 0 that is equivalent to 1. So, therefore, e to the 2x, 1 plus 1, that is 2, plus e to the negative 2x. So, e to the x plus e to the negative x squared equivalent to e to the 2x plus 2 plus e negative 2x. We are going to rewrite this one. This is now equivalent to the integral of e to the 2x plus 2 plus e negative 2x, that is dx. The integral of e to x dx plus 2, the integral of dx plus the integral of e negative 2x dx. U is equal to 2x, du is 2 dx. Here, u is equal to negative 2x, du is equal to negative 2 dx. The integral of e to x 2 dx. So, multiply 2, multiply 1/2. Plus 2 dx. Plus the integral of e negative 2x. Negative 2 dx. 4, multiply negative 2, so multiply negative 1/2. Okay, so our final answer, that is equivalent to 1/2 e 2x plus 2x minus 1/2 e negative 2x plus c. So, this is now our final answer. This example is e t. The next example is e to the t minus e negative t dt. So, we will have the integral of expand e to the t minus, so next example, that is e to the t minus e negative t squared dt. So, if we are going to expand that one, we will have e to the 2t minus 2 plus e negative 2t dt. So therefore, you will have the integral of e to t dt minus the integral of dt plus the integral of e negative 2t dt. So u here is 2t, du here is 2 dt. U here is negative 2t, du is negative 2 dt. So back to the form, you will have the integral of e 2t, du is 2 dt. Multiply 2, so multiply 1/2 minus 2 dt plus the integral of e negative 2t, du is negative 2 dt. Multiply negative 2, so multiply negative 1/2. Okay, so therefore, our final answer, that would be equal to 1/2 e to the u du. So we'll indicate here. This is now our du, e to the u. This one is our du. This one is e to the u. So our final answer will be 1/2 e 2t minus 2t minus 1/2 e negative 2t plus c. So that is now the final answer. So that is now the final answer. So we will have our next example. So next example is the integral of 2 to the x dx. So our u here, where, okay, u is equal to x, du is dx. So therefore you will have, this is now a complete form, the integral of 2 to the x dx, wherein this is now a form of e to the u du. So once you will have a form of e to the u du, so note, okay, I will write here note, the integral of e to the u du, it is equivalent to e to the u over a to the u ln of a plus c. So therefore our answer, that would be equal to a to the u, that is 2 to the x, over ln of 2 plus c. So that is now our final answer. Okay. So our next example, that is the integral of 10 to negative 3x. That is a number to a variable. U is equal to negative 3x. du is equal to negative 3 dx. So therefore, that is equal to 10 negative 3x. du is negative 3 dx. Multiply negative 3, so multiply negative 1/3. So if we are going to look at this one, this is now a form of du. This one is a to the u. So because that is a form of a to the u du, proceed now to the formula. We will have negative 1/3. So you will have 10 negative 3x over ln of 10 plus c. So that is now our final answer. Okay. Note, the integral of a to the u, that is a to the u over ln of a plus c. Next example, that is the integral of 2 negative x dx. So where u here is negative x, du is negative dx. So you will have 2 negative x negative dx. So multiply negative dx. So you will have negative 1. This is du. This one, a to the u. So a form of a to the u, du. So we will have negative 1. Then you will have 2 negative x over ln of 2 plus c. So therefore our answer will be negative 2 raised to negative x over ln of 2 plus c. So that is now our final answer. So note here, note the integral of e to the u du, that is equal to a to the u over ln of a plus c. That's it. Thank you.